Okay, let's get started. Is there any question before we get started? So today will be lab 13, which is the last lab you're going to have. After you finish the lab 13 should be pretty quick. So after you finish lab 13, you will start to do the final project. Okay, so try to start the final project as early as possible. Since this is summer semester, so you have limited time for the final project. Okay. 1 second. Let me start share my screen. Okay, so first of all, I want to talk about the final project really quick. Just so if you see your right space, there are a couple documents you have. First of course, try to read through the menu really quick before you start the final project. Okay, this menu talk about uh, the basic theory of the final project. Okay, and there is another document called equalizer topology. So this one gives you a reference of the circuit you're going to build for the final project. So it's not going to exactly, you may not going to use exactly same circuit, but this one give you a reference. Okay, I will talk about more about final project next Tuesday, but make sure you read through the document before as soon as you finish lab 13. Okay. All right, so let's talk about lab 13 right now. Okay, so lab 13 is about rectifier and voltage regulator. Okay, so last week, or no, last week, this Tuesday, you already learned about a rectifier. So the rectifier have one feature is the feature is the current can only go through one direction. Okay, so for example, the current can only go through this direction if you remember the experiment. So we can use this property of the diode. We can make a voltage rectifier. So basically the function of voltage rectifier is transfer the AC signal to DC signal. Okay. So for example, your cell phone need a DC voltage to charge it, but the signal from from the outlet is the AC signal. So we will need a rectifier to transfer this AC to DC signal. So first of all, it's a half wave rectifier. So if you only have one single diode, you can transfer a AC signal to a half wave signal, or almost a DC signal. But if you only have one diode, this will waste another half of signal. So what we can do is we can have a full wave rectifier. Okay, so in this case, all the signal can transfer to positive signal. But as you can see here, still this signal has a very large ripple. Okay, so then what you can do is you can have a capacitor to make a signal much smaller. Okay, so something like this. And here is an equation. Calculate the capacitor, the period, and the DC, and the voltage, the resistor load, and also the ripple delta V. So the relationship between them. Okay, and let's jump for the reference part. Okay. And the last thing I want to mention here is uh the adjustable linear regulator. So uh by using some AC chip, I mean IC chip, you can have adjust output voltage by easily just change some variable resistor. Okay, so you're going to build this circuit in the LT space today. All right, let's jump into the tasks. Okay, so today all the tasks will based on LT space. So that's why I mentioned today's lab should be quick. So first one is a half-wave rectifier. Okay, so you're going to build this circuit in the LT space and measure the output. Okay, then you are going to build the full-wave rectifier and similarly measure the output. Okay, make sure you measure the peak-to-peak voltage and also the it just measure the peak-to-peak. And also make sure you take a screenshot of your output. All right. Another thing I want to mention is, okay, it's not mentioned in here, but the ground for the half-wave rectifier is right here. And the ground for the full-wave rectifier is right here, okay? Make sure you're not connecting your ground right here, so that's not correct, okay? Then you're going to build this circuit right here, okay? Which is the voltage regulator circuit. First of all, in the LT stress, you're going to use the LT1117 instead of LM1117. Okay, they are same. They are the same function over here. And another thing, you may notice there is no variable resistor in LT space, so you're going to manually change the variable resistor. Okay. All right. So, question number one is just build this circuit in LT space, and again the ground is right here. Okay, so here is not the ground. Make sure you're not connecting your ground right here. Okay, so after you build the circuit, firstly, you measure the weight rect, which is the voltage right here. And then you can try to manually adjust the variable resistor right here from 0 to 10k ohm to see what will be the minimum and maximum of output. Okay, output voltage. And then you just follow the instruction, adjust the variable resistor until the output is exactly at 3.3. Then you can replace the RL to 1K, 100 ohm, and 47 ohm to measure the weight rect and the weight out at those three load resistor. Okay, then just follow the instruction to do some calculation. The repo ratio equation you can find in the lab manual. Okay. See anything else I need to mention? I will show you how to build the delt into LT space in 1 second. Any question for right now?
So
Yeah.
to do this lab, we like everyone has to use LT Spice, right? Like there's
Yes.
no
Yes.
physical
Yeah. No
component.
physical. Yeah. Yeah. Just use LT space.
And when it says above for the pre-lab, you only have to do task one. Uh,
Let me show you real quick. So just this task right here. So you don't have to do there was a task two, so it's not written in here. So you just do the first task. Please just answer these two questions. Okay. Any other questions? Okay, give me 1 second. Let me open LT spec so I can show you the delts. Okay, so for the delt, so what you need to do is firstly, you make a new component called delt. Okay, so you just put here somewhere at your circuit. Okay, then this is a empty delt. So if you right click on it and pick new delt, so you can pick whatever the part number you want. Okay. So if, for example, I pick 4148, then this delt will be 1N4148. Okay. All right, I think that's all for today's lab. Just make sure after you finish Lab 13, start the final project as soon as possible. Yeah, and also I will open the breakout room if you have specific question. There's a question asking, is there a take-home portion for Lab 14, which is final project? There's no take-home portion, but you have a pre-lab. Okay, the pre-lab for final project is not going to be graded, but what you can do is the pre-lab of Lab 13 is letting you to like write down the circuit topology you're going to use. Then you submit in the pre-lab and we can check it to make sure you're on the right track. Okay, so although it's not going to grade it, I still strongly recommended you submit on the Brightspace so we can check it, make sure you're on the right track before you go too far.
Will there be any undergraduate TAs for today?
Yeah, we do have a UTA right now in our main section. If you have if you want individual help, I can go to a breakout room also.